Okay, returning to our discussion of data sufficiency questions, and more specifically of the yes-no type of data sufficiency question. Let's take a look at number 16 here. Is X an integer? Well, you'll notice that this is a yes-no type of data sufficiency question. We have to evaluate each statement individually and see if it answers the question, is X an integer? And what we're looking for in order for a statement to be sufficient is we're looking for a result where the statement tells us that yes, X is an integer, or no, X is not an integer. If we get to a result where sometimes yes, X is an integer, and sometimes no, X is not an integer, then that statement is going to be insufficient. So let's evaluate the two statements here and see where it gets us. Statement number 1, X over 2 is an integer. So the possible values we could plug in for X in this situation would be values like 4, because 4 over 2 gives an integer result, which is 2. We could plug in 6 for X, because 6 over 2 gives an integer result, which is 3. And you'll notice that in order for X over 2 to be an integer, X itself must be an integer. So the answer is yes, X is an integer, and statement 1 is going to be sufficient. Next, we have to evaluate statement 2. And remember, we're evaluating this statement independently of the information in statement 1. So statement 2 says 2x is an integer. Now again, we can plug in a value like 2 for x, and of course 2 times 2 would give 4, which is an integer result. However, you notice that in statement 2, you could plug in a value like 2.5 for x. And if you multiply 2.5 times 2, you still get an integer result. So the starting value for x, it could be 2, which is an integer, or it could be 2.5, which is not an integer. So statement 2 is in fact getting us to a sometimes yes, sometimes no result, where x is sometimes an integer and sometimes it's not. So statement 2 is going to be insufficient in order to answer the question, and the correct answer choice is going to be A, which is that statement 1 is sufficient and statement 2 is insufficient. We had a question here from Al.
Unmuted.
Yes, so in example number 1, since if x is an odd number, then x over 2 would produce
Okay, well basically statement 1 is
whole number plus.
Well, yeah, you're right about that. Statement 1 actually tells us not only that x is an integer, but it tells us that x is an even integer, because you really only can plug in even integer to the statement 1 in order to get the integer result. So statement 1 actually tells us that.
Okay, I see.
Okay.
Yes.
That example was pretty straightforward, and I'd like to move on to one that's a little more involved.